So, really this one's labeled number 1 on your graph, but I changed it to number 3 on mine, so, because I can't. What do I need in order to make the equation of this graph? One thing that I need. The period, okay? How am I going to find the period? Okay, so that's going to give me a horizontal distance of 6, right? Okay, so that means that my period is equal to 6. So 2 pi divided by b is equal to 6. So pi over 3 is b. Do we all agree with that? Okay, that's one thing that I need. What's another thing that I need? Eddie? Amplitude. How am I going to find the amplitude?
No, just find the midline.
Okay, what is the midline?
5.
5? Why did you choose 5?
Because I counted up and then divided by 2.
So 8 plus 2 is 10, divided by 2 is 5?
Well, I just counted 2 to 8 and then I divided by 2.
Okay, so 6 total distance divided by 2 gave me an amplitude of 3. Okay, I like that. So my middle here then, you said was at 5, which makes my amplitude 3. Okay, okay. Okay, that's 2 more things that we need. Now, what's the last thing that we need? You gotta have 4 things. The start. So it's really wherever you decide to start. Okay? So, I would say here that this cosine curve, y equals 3 cosine of pi over 3 times x. Now, I'm going to start on the first one because cosine starts on high. So that would be x minus 1 plus 5. Agree with me on that? Okay? Now, this number in here could change if I went to the next high point, right? The next high point is at 7? 7? Yep, so that would change to a 7. If I went to the next high point after that, that would be at 13, right? If I went to the next one after that, that'd be at 19. What if I went to the left another high point? Then that number in here, this number, would be plus what? 5. Next one, plus 11, plus 17. How am I getting those so quickly? That distance is always 6, right? So you just keep moving it over 6 spots. So that's a quick and easy way. Right there, we just came up with 7 different cosine curves for that one. Okay? Now, if I wanted to start at the low point, then this would be y equals negative 3 cosine of pi over 3 times x minus 4 plus 5. Right? And then this number could change to minus 10, minus 16, plus 2, plus 8, etc., etc., etc. Right? Based off of that period. Yeah. Now, extension question for you. Find me a sine curve. Same graph. find me a sine curve. What's the downfall? Or, let me immediately, Nat, I want a different question. Strike that last question. Amplitude stays the same? Yep. Middle stays the same? Period stays the same? Yep. That period stays the same too. What's the only thing that's different? Start. Where am I looking now for the start? I'm looking on that middle line, right? Okay. So just looking at this particular middle point right here, where is it? 2.5-ish maybe? Okay. So it might, based upon your graph, you might have to adjust. You know, in this case, cosine is easier because we have the peak points and the valley points. The middle points, not necessarily the best. Okay, so I could go here, and so 4, 5, 6. So we could go with y equals -3 sine of pi over 3 times x minus 5/2, because that's 2.5, plus 5. Okay. Or we could go with y equals 3 sine pi over 3 x. I gotta add 3, 11. No. Yeah, 11/2 plus 5. Okay. Or adjust the period, or adjust the start based off of those. Okay? Handle? What I'd like to do now is I'd like to do the last page in your packet. That last page in your packet is going to deal with tides and the depth of water. So throughout the day, the depth of water at the end of a dock varies with the tides. The table shows the depths in meters at various times during the morning. High tide is at 4 a.m. and low tide is at 10 a.m. Okay? So what I would like you to do first is I would like you to graph those data points. Go. First question, do I need any negative numbers on my graph? Let's talk x's first. Why do I not need negative x's? That's negative time. That's going back in time. Talk y's. Why don't I need negative y values? Think about the scenario. What are we talking about here? Nope. Nope. Why don't I need negative y values? What? No. What are we dealing with here? Water. Depth of water, right? And if there's no water, what's the depth? 0. Can I have a negative depth, a negative 2 feet of water in a lake? No. Okay, so I don't need negative numbers. Okay? Oops, this one. So, okay. 1, 2, 3, 4, 5. That's my depths. 0 is going to be at midnight, right? 2.55. Right about, let's go that one. What about the? Okay. 2, 4, 6, 8, 10, 12. Oops, I should put those in there. 2, 4, 6, 8, and 12. Okay, so at 2, 3.8. At 4, 4.4. At 6, 3.8. At 8, 2.55. At 10, 1.8. And at 12, 2.27. Agree with that? Okay? Upon first glance, what kind of a curve, if we're looking ahead to part B, write an equation to model the data, what kind of a equation would we write upon first glance? Sine, right? It looks like a sine curve. Okay? Right? Now, I'm okay with that. Okay. We also know that this point in here is my low tide point, and this point up here is my high tide point, right? What do I need to make that equation? What do I need? Why do I need to average them? Gives me the amplitude and it gives me the middle, right? Okay, so I need to average that one and that one. 4.4 plus 1.8 divided by 2. .4 plus 1.8 divided by 2. 3.1. Okay, so that tells me that my middle is 3.1, which means my amplitude is what? 1.3. Now, I am going to put upon my graph at 3.1 my midline. Okay, it looks straight. Didn't look straight, but it is straight. Okay? What do you mean 2.6?
Oh, just kidding. I lied.
Okay. All right. Okay. All right. With me? Okay. Good so far. What else do we need to make let me draw my curve in. See if that helps us. Yeah? What else do I need? Period, right? Okay. So my period would be from like here all the way back out to there. Right? But I don't know what that time is. I could probably figure it out, but I don't know. Okay. Is there another way? Is there another way to find the period? So, from the high to the low, that's half a period. In sine and cosine, from the high to the low is half of a period. Okay? So what is that horizontal distance? 6 hours, right? So what is my period then? So my period is 12 hours. So 2 pi divided by b is equal to 12. So that gives me b is equal to pi over 6. Right? So now I've got my A, I've got my B, and I've got my D. I just don't have my start, right? Okay? Now, back to the actual graph here. Okay? If I were to make a sine curve, I'd start it in the middle, correct? So that means I would have to start with right about there. What's that approximate value? Somewhere between half and 1, maybe, right? Okay. 0.75. Okay. All right. So if I make my sine curve, that would be y equals 1.3 times the sine of pi over 6 times x minus, what do we say, 3/4? Plus 3.1. Right? Okay. Not bad. I got to do some estimating, which might be tweak my answers at the end a little bit. Okay. What is a more, for lack of a better term, a more accurate trig function to use here? Why would cosine be more accurate? Because we have the high point, right? We know what that high point is. So we know that start is locked in at 10. Or no, excuse me, at 4. Okay? So we know that the cosine curve might just be a little more accurate. Okay? So we've made an equation now to model our data. Sweet sassafras. Because now part C says, use that model to find the depth at 9 a.m. and at 3 p.m. Okay? So my question to you is, at 9 a.m., what is my x value? At 9 a.m., what is my x value? Yeah, trick question. No. Because midnight was 0, 4 a.m. was 4, 10 a.m. was 10, so 9 a.m. is 9. Okay? Non-trick question now. Okay? 3 p.m. is an x value of what? 15. Okay? You find me now those depths using either one of those. Ideally, they would be identical, but they might be just a little off. Way over. So, if I use the sine curve, or the sine example, the sine model, that's the word I'm looking for, model, I get a depth of 1.89896 meters. If I use the cosine model, I get 1.97417 meters. Judging by some of your faces, you didn't get that. My guess is that you are in degrees on your calculator, and this is a radian function. Is my guess. On the 3 o'clock, at the 3 o'clock hour, my sine function gave me 4.30104, and my cosine function gave me 4.22583, both meters. Okay. Now, let's go back and look at our graph. You know, my graph's going to get all full of all these different lines and stuff. Okay? Let's see, what can we clean up? We can get rid of that line. I'll use this one. So at 9 a.m., I'm right there, which means I'm right there, correct? So that means then that I would be looking at something less than 2, according to my graph. 1.89 and 1.97 are less than 2. So that accurately fits my data. Okay? So those are good. That's one quick and easy way to check that I'm in the ballpark. 3 o'clock, I'm going to have to go. There would be 2, there would be 4. You know what I mean? I'd have to go over here and try and find where it's going to be. It should still be on the uptick. I didn't do a very good job, apparently, of drawing my uptick. It should be somewhere in there, right? Which would be a little bit over 5. 4, yeah. I didn't really do a very good job with my curve over there because I didn't have data points over there. Okay? But I'm close. Right? Okay. Last question. Question D. Question D says that a boat needs at least 3 meters of water to motor at the dock. During what times in the afternoon is it safe for that boat to either leave the dock or come into the dock? Okay? Now we're talking afternoon, correct? Okay? So what did you notice about your graph? Oops, I should bring the scale back in. Now you can see it. We got,
if the period is 12 hours, can we just use the morning points?
Exactly. Your period's 12 hours, so you can use the morning points to figure out what it is. And just change AM to PM. Okay? So we need basically where that boat is above our center line, our middle line, right? Or where, I shouldn't say where that boat is above, where the depth of our water is above our middle line. Okay? So that would be, let me go into a different color scheme here. Haven't really used purple yet. So that would be here and then to there. So I would say roughly 1245-ish, right? To 6:30? 7:30, I mean? Right? Because the middle here would be to like 7:15. Okay? So that's what I would go with here. I would go 1245.
Wait, so you don't actually do it with the equation?
You could. I had 30 seconds to do it though, so I went off the graph.
So if you did it, you just do like that?
Yep. And then
Then
you
how would you
exactly. Yeah. Ugh. Graph's a little easier. Alright? Tomorrow we're going to do temperatures. We're going to talk about Honolulu, Hawaii. And Chicago, Illinois. Illinois.